Hey, this is review assignment 3. So this first one is a problem you can use your calculator on. So we're just going to, it's an area problem. Most of us are really good with those. Yeah, I would suggest always, number part A says find the area. I would always start by showing a graph. So the graph of this one looks something like this. You got a line, I think you can see its y-intercept is 4. So that's 4 up there and it's headed down this direction. The other graph ends up looking something like that. So the area bounded by the y-axis in those two ends up being that area right, and I'll do the different color. Ends up being that area right in there, that area that we're doing. Okay, so we want to find that area. Most of us are really good with this. Just make sure you go top minus bottom. Don't mix this up with volume. This would just be the integral of 4 minus 2x minus x cubed over 1 plus x squared. Now I do have to find my limits. The lower one is 0. Okay, the upper one, we talked about this later on. This is what I want to emphasize is you have to find where the two intersect right here. Okay, and you have to show how you found that. So as part of your work, if you remember, you don't have to do everything because it's a calculator problem, so you can use your calculator to solve it. But you need to see at least this if you want full credit. You have to show that you set them equal to each other and you solved it. So you would minus those over there, get everything on one side, graph it, find the zeros. It comes out to be like 1.488. And you can either store that in your calculator or do your 3 decimal places. Okay, so there's my upper limit up here. Because up here it's 1.488. Okay, so there's the area. The volume most of us are really good with. This one is revolving around the x-axis down here. For revolving around the x-axis, that means I go, if I'm going to do this would be a washer. This would be my cross section. And that works good. I know that equation in terms of x, I know that equation in terms of x. It would be pi times top minus the bottom. So big R is a distance from there to there, that distance right there. So that would just be 4 minus 2x minus 0. There's my big R squared. Minus my little r squared. That's the distance. I'm going to do this a different color. They're very colorful up here. Distance from there to there. So that's just that bottom function. That would be x cubed over 1 plus x squared squared. And then I know we're still going from 0 to 1.488. Thankfully, that's a calculator problem. We can just punch that in there, and that ought to give us our answer. Hey, the one we have a harder time usually with is part C. Part C is the region R is the base of the solid, and we're doing a cross section. So the cross section is perpendicular to the x-axis. So we're going to set this up first of all. It's perpendicular to the x-axis. That means it's going to be a dx. And remember, you always start with what is the area of your cross section. So the area of our cross section in this case is perpendicular is a square. So now I have the integral of, we know the formula for a square is that. All I have to figure out, by the way, my limits are going to be the same. We're still going from 1 to 4.88. All I have to figure out is how do I represent the side of the square. So remember, you're picturing a square. There's my cross section, and the square is coming up out of that. So it's coming up out of here. Well, that side right there then is just the top minus the bottom. So S on that problem is going to be just the 4 minus 2x minus x cubed over 1 plus x squared. Okay, that's what S is equal to. Now I'm going to take that and plug it in for S right there. That gives me my answer. So make sure you remember how to do a cross section. Also, make sure you include this part right here. Like, how did you find your bounds? Okay, that needs to be included in there. This one's really similar, except for part B. Part B is kind of crazy. So I think I want to show you part B. Part A, find the area of region A. That's easy. It's just the integral of 1 over the square root of x from 4 to 9. Right, that gives me the area. If you look at B, it says if the line x equals k divides the region R into 2 regions of, oh, by the way, this is a calculator problem also. When you solve this one, it comes out to be 2 up here. That'll be important for this one. So if the line x equals k divides the region R into 2 regions of equal area, what is the region of K? So what you're picturing here is, instead of going from 4 to 9, we're going to go from 4 to K. You have that line equals K that's splitting it in half. And I have to integrate 1 over the square root of x dx. And when I get my answer, it has to equal half of the area of R. Well, the area of R from part A came out to be 2. So that's got to equal 1 right there. So now I have to integrate that, plug in K and 4, and find out when it's equal to 1. So let's do this part right here. If I integrate x to the negative 1/2, right, I get x to the positive 1/2 divided by 1/2, which is 2. So this, then I'm going to evaluate that from 4 to K. X to the 1/2 is the square root of x. So I end up with 2 square root of K minus plug 4 in. So 2 times the square root of 4. So, and that has to equal 1. The 1 came from up here, right? That equal 1. So I have 2 square root of K minus 4 equals 1, and you would solve it the rest of the way from there in order to get your answer. Volume, like I said, this is a cross-section problem again. Give that one a try. This squares again. So it's really similar to that last problem that we just did on number 1. I'm going to leave this one. Most of us are pretty good with this. The only tricky thing about this is you are going to revolve it around the vertical line. So when you go to do that, you got to think about, if you're doing the disk or washer method, you're going to have to change, you're going to have to make it in terms of y. Or you can try the shell method. You can do either one, but I'll let you try those. You can check the answer sheet if you need to, solution sheet if you need to. Whoops, never deleted this one. So on this problem right here, this one I thought was a little bit tricky. A couple things I wanted to talk to you about. So it says show that L is tangent to the graph of f of x. So if L is tangent, it has to have the same slope. So we already know the slope of L is, and that's in the, it's -3. You could find the derivative, but it's a linear equation, so we can just find the slope by looking at the y equals mx plus b. So I want to show at this point right here, what does it say? When x equals 3, I want to show that the f of x has the same slope. So what I want to find is, what is f prime of x? Then I'm going to plug 3 into it. So f prime of x would be 8x minus 3x squared. So now I'm going to find f prime of 3. So that'd be 24, 3 squared is 9, 9 times 3 is 27. I subtract those. And so, whoops, not 27, sorry, that'd be -3. So what I just showed is at 3, f has a slope of -3. So they got the same slope right there. Okay, so that means that it is tangent to it. So what I may want to talk about is how to find region S. That's the main one I want to talk about. When I go to find region S, the tricky part is, that's this region right here. I cannot do one derivative with this. And the reason why is because from there to there, I have to do washer. From here to there, from when x equals 3 to whatever this point is, I've got to do the washer method because I got to go top minus bottom, right? That's my cross section right there. There's my rectangle that I'm setting up. From here on, I can just do the integral of s. It's just going to be a wash, it'll be disk. So when I go to find this one, I got to find this point right here. This is where it changes from right there. From that point on, I'll just be doing the disk method with s. So I got to figure out what that is. That's when f of x is equal to 0. So the first thing I have to figure out in part A, or part B, sorry, is when is f of x equal to 0? So I'm going to take 4x cubed minus 4x squared, sorry, minus x cubed equals 0. You can factor out an x squared times 4 minus x equals 0. So it's equal to 0 at 0. That's that point right there. And it's equal to 0 at 4. That's the one we're looking for, is right there. So I'm going to have to do two integrals. I'm going to do the integral from 3 to 4, from right there to right there. And then I have to go top minus bottom. So think of your cross section. The top is the line. that would be the 18 minus 3x minus the bottom, which is r. That is the 4x cubed, 4x squared minus x cubed. Okay, that's going to give me this area right here. Plus, now I have to do the integral of 4 to, I need to find out when s is equal to 0. That's where it's going to end at. So I got to come up here. When does 18 minus 3x equal 0? So you add the 3x over, divide by 3, it's at x equals 6. On that one, this cross section, right? So go through here, that's just washer. And not washer, sorry. I don't know why I'm saying disk and washer, refining area. But that's just top minus bottom. So that would be the 18 minus 3x minus 0. So you have to split it into two different parts. They're kind of tricky. C is not bad, but just make sure you recognize on C, it's asking for area R. Area R has nothing to do with this. It's just f of x right there. This will just be the integral of f of x. We're finding volume now. So squared from 0 to 4 pi. And that'd be the volume right there. So that one is a little bit tricky. Let's see. This next one, not a whole lot on here other than just recognizing on this problem, this last one, you need to split it up too, right? On this one, the 2 to the x is on top and the x squared is on the bottom. Up here, the x squared is on top and the 2 to the x is on the bottom. Make sure you show, to find those points of intersection, make sure you show that equation right there. But other than that, this is really similar to most of the other volume and area formulas we've done. And most of us do a pretty good job with this one. So anyway, give all those a try. If you got questions, you can ask me. You can look in the solutions manual. But again, practice on showing your work on each step. Do not try doing these problems on the pages. If you have, then stop. Like if they're free response problems, I want you to do them on a separate sheet of paper, and I want you to show your work. Thanks.